So today we're going to talk about coding a simple tic-tac-toe game in C#. I have the running application here, so as we click a box we get an X because player 1 obviously is an X. Now I'm going to play as player 2 also. I'm going to click another box and you see we get an O. Once we click the boxes they are disabled, so we can't click them again. So now it's player 1's turn again. They'll play there. 2 will block here. Player 1 will go there. 2 will play here. And as you see, player 2 now wins because they got tic-tac-toe, a diagonal with 3 O's. So let's talk about how to code this application. So I've got it started here. I went ahead and created 9 buttons and labeled them BTN1 through BTN9 and created a label called tic-tac-toe. Pause the video and create 9 buttons and the label now. Okay, so you've created your 9 buttons and your label. Now it's time to code the button. So if we double click the first button here, we have obviously blank, no code yet. The first thing we need to do is declare a global variable called label and set it equal to nothing. Now what that's going to do is that's going to hold the value that should go in the button, whether it's going to be X or whether it's going to be O. We're going to give it where it looks like the program's smart, but it's actually just an if statement checking this label variable to see what its value currently is and then knowing what to put in it the next time. Now the code I'm giving you here we need to do for each button. Now let's look at the code that I've put in here for button 1. So if the label is X, we're going to set the label to O, and then we're going to write the value of label to btn1.text, the text property of the button. If the label is any other value, we're going to set it to X and then write that to the label, and we're going to turn off the button so it can't be clicked again during that game. Now label can only, in this program, only have 2 different values, so that's why we can just use a blanket else here. It's only going to be X or O. There are no other possible values we can give it because it's coded into the program. The user has no way to modify the value of label, so there's no reason to do an else if. It can just be a blanket else. Remember, to check equality in C# we have to use the double equals and not the single equals. And after that we're going to call a method called when. Now I have an error here. The name when does not exist in the current context because I haven't coded when yet. Pause the video, double click each button and add this code, remembering each time to change this statement to the number of the button you are coding. Now with all the buttons coded, you see we have 9 errors, each one the same error saying that when does not exist in the current context. And as you see on the right here, we have red dots for each error on the scroll bar. So what we're going to do now is we're going to actually create the method declaration for when. So private. Now we don't need to return a value back to the program. We know that because the way we called when. We just called it here, not setting it equal to a variable, just calling it. This is like a private sub in Visual Basic, so we don't need a return type. So we're going to type void, and then we're going to type when. Then we're going to put in our brackets. Now you'll notice all the errors go away. Even though when has no code in it, it now there's a valid method declaration there, so it can call the method. The compiler doesn't care that there's no code in it. It just can call it now, so all the errors immediately go away now that we have declared a method called when. Now remember, like a sub in VB, a function in C# would look something like this. So we can expect to return a string here, and you see we get an error, does not return a value. I'll just put in return for a moment. I'll just put that in right now so the error will go away. But you see, this is like a function. When we have a data type after private instead of void. But we don't need to return anything. So I'm going to erase this, and we're going to go back and look at the win variable. Now the first thing we need to do is we need to figure out if a player has actually won, which means they have 3 X's or 3 O's. Now, on a tic-tac-toe board, there are 8 possible ways to win. Across each way is 3, down each way is 3, and diagonally, creating the X, is 2. So there's 8 possible ways to win. We need to code each of these possibilities. Now we're going to use compound if statements to do this because we actually need to check for 3 different values being a certain way, either X or O. So this method actually has 16 statements. We've got to check the 8 X's and then the 8 O's. So let's start here. So if we'll make it simple, we'll go straight across. So our buttons are numbered 1 in the top right, 9 in the lower left. So if we say if btn1.text equals X and btn2.text equals X and btn3.text equals X, then we're going to do some things. Now remember from the previous lesson, the double ampersand is the and. Remember we use the word and or and also in VB. The double ampersand is the short circuit and in C#. So if btn1.text does not equal X, there's absolutely no reason to look at the other 2. If the first one isn't true, the statement can't be true, so we're not going to look at all of them. So that's what the double ampersand is. It's short circuit and. So if all 3 of these happen, player 1 wins because player 1 is X. So we're going to put a message box up here. So message box.show player 1 wins. So we need to do that for each of our 7 more conditions for X and 8 conditions for O, changing player 1 to player 2. You can write all the X statements and use find and replace to change the X's to O's and the 1 to 2. So let me show you how to do that. So now we're going to say I'm going to take this and I'm going to copy and paste it. So now I have 2 different if statements here, but I want to highlight this one, and on the keyboard I want to press Control and the H key, and that's going to open find and replace. So I want to replace X with O, and I'm going to hit this button right here, find next, and it's going to tell me, it's going to show me there, and there. Then I can click this button right here, replace all, and it's going to tell me that it replaced 3 occurrences. I'm then going to type 1, change it to 2, click find next. It's going to tell me that find reached the starting point of the search. Okay, so it highlighted here and told me it reached the starting point of the search. I'm going to replace it, and now we see player 2. So now we have the X coded and the O coded for the first win condition. Pause the video and code the remaining win conditions for X and for O. Also, we're going to add one more thing in here. We're going to add another method called IntelliSense there, because I don't have this method. We're going to add another method called clear. What clear is going to do is, after someone wins, they're going to reset it's going to reset the game for a new play, to play again. So after the message box, we're going to put clear in each method. So pause the video and add all the win conditions now. If you're paying careful attention, you realize that there were 16 win conditions. However, there are 17 errors. Well, the last condition is the draw condition. So all 9 buttons have some value other than string.empty. Remember, this is C#'s way of checking for inequality. So if all 9 boxes have an X or an O in them, that means that doesn't equal string.empty, we have a draw. So we're going to tell them it's a draw, and we're going to still run this clear method. So let's define the clear method now. So private void clear. Oops, let's try that correctly. There we go. Now, in this method, we need to set up some things. We're going to say btn1.text. We're going to set it back to string.empty. Lowercase t, or s, not uppercase. So we're going to do this for each button. And notice I'm letting IntelliSense do a lot of the work here for me. Instead of typing everything out, I'm letting it do a lot of it for me once it knows what I'm doing. And I'm pressing the tab key to have it make a selection once the correct selection is highlighted. Not tab index. Got too happy with my IntelliSense there, and it had it made the wrong selection. Okay, I also need, remember we disabled each button so it couldn't be changed. So I need to re-enable all the buttons. However, I don't want to type 9 lines of code again. So we're going to use our handy dandy find and replace here to fix that problem. So I'm going to copy and paste where I have the same code, 9 lines of code now, twice. I'm going to highlight the second coding block and press Ctrl H. I'm going to look for all cases of string.empty, and I'm going to change it to true. What we're going to do is we're going to set the enabled property to true. Notice my 9 are highlighted. If all 18 of yours are highlighted, that means you forgot to select the bottom 9 line coding block. You don't want to do this for all of them, just for the second group. So if I come over here and press replace all, it's going to replace it, but now it's going to create 9 errors because text can't equal Boolean true. So we're going to make another change here. Dot text becomes dot enabled. And we're going to replace it again. Now our errors will go away because enabled is a Boolean property and it can be set to Boolean true. So our clear method is now functional, and if we run our game here, we will see that we can now play like we did at the beginning of the video. We have a draw. This time O's going to win. There we go. So we have a functional game. Now in our next video, in part 2, we're going to enhance this game to ask for players' names and ask how many games will be played and keep score. Player 1 has won 5, player 2 has won 3, and so on. So join us in the next video to enhance our tic-tac-toe game. There's also a walkthrough posted in the PLC teachers that gives you a step-by-step Word document walkthrough of how this was coded, including all of the code.